Hi, and welcome to video 4 of Module 1. In this video, we're going to be talking about 3 additional sampling techniques. The 3 sampling techniques we'll discuss in this video are all different kinds of random sampling. This video builds on the previous video and we'll be making reference to it frequently. If you would like to rewatch that video, click on the button to the right. As a quick review, the 3 types of sampling that we talked about before were a sample of convenience, which is an easy sample to do, not super hard, a voluntary response sample, which is when the participants choose to participate in the sample, and the 3rd type is a systematic sample. That's the one where we interviewed every 4th monkey in our list of monkeys. Also to review, for each of our sampling techniques, we are going to be pretending to be a paint company that has branches in San Diego, California and Boston, Massachusetts. And we're interested in knowing if people on the West Coast paint their homes a different color than people on the East Coast. So we're going to find some different sampling techniques so that we can investigate this question further. The 4th sampling technique is the easiest type of random sample to determine, and this is called a simple random sample, which we'll abbreviate with an SRS for short. We'll frequently be talking about the size of a sample throughout the course, and we'll use a lowercase n to represent that. So if my sample consists of 50 people, n would be 50. So here, a simple random sample of size n is a sample that's selected from the population, where each member is equally likely to be selected. And it's that equally likely part that's super important. That's the statistical definition of random, that everything has an equal chance of being selected. As a visual illustration of how a simple random sample might be selected, let's say we have a population of sea creatures. So here we have some fish and crabs and some sharks, right? Let's say this is my population. If I want to find a simple random sample of these critters, my first step is to number the population. And I can number them however I want to. I just need to give everybody a unique number. Typically, we'll start with either a 1 or a 0, depending on the method of randomization that you're going to be using. So in this case, I'm starting with 1 and numbering through 15. Then, in step 2, we're going to use a random number generator to select a sample of size n. In this case, I'm going to choose a simple random sample of 5 sea creatures. And I did this by going into Excel and using what's called the ran_between function to get 5 random numbers. You don't have to use Excel. Many statistical and scientific calculators have a random number generator on them. Other ways, you can roll a fair die, flip a fair coin, depending on your sample size. And in the olden days, they used random number tables. So lots of different ways to generate random numbers. In this case, I went to Excel and I found 5 random numbers. The numbers Excel got for me were 11, so I would take number 11, 1, 6, 14, and 3. So all the other fishes disappear, and these 5 sea creatures would constitute my simple random sample. Okay, so let's see how our paint company might find a simple random sample. The paint company obtains a list of all the residential addresses in San Diego and Boston. Using a computer, they randomly select a list of 200 addresses in each city and determine the color of those houses. Our clue here that this is a simple random sample is that they used a computer to randomly select a list of 200 addresses. They didn't do anything fancy with the randomization. In a minute, we're going to look at some fancier randomized sampling techniques. In this case, all they did was they just made a list and then randomly selected 200 addresses. So this would be a simple random sample. Now, one last comment about simple random sampling. You can also think of this like a lottery, right? When you play the lottery, every ball that has a number on it is equally likely to puff up to the top. Or if you've got a raffle going and you spin that big thing that's got all the tickets inside, every ticket is equally likely to be selected. Before we talk about the fancier random sampling types, I want to do one more example of finding a simple random sample. In this example, the 12 most populous cities in the United States, as of 2012, are given in the table to the right. Now Kevin wants to select an SRS of 5 cities from this list, so his N would be 5. He uses his calculator to generate the list of random numbers below, and we want to know what are the 5 cities that Kevin is going to use for his sample. Now, depending on your teacher, they may ask you a question similar to this one or maybe slightly differently. For example, your teacher might ask you to use your calculator to find a simple random sample of 5 cities. So in that case, instead of generating this list below that Kevin made, you would just generate your own using your calculator. So how you get your random numbers might be different depending on how your teacher is asking you to do this kind of example. So in this case, these are the numbers that Kevin got on his calculator. So whatever calculator he used, the first random number it gave him was 0, and then the next one was 10, and then 11, and so on. So a couple things I want you to notice. Thing number 1 is that even though Kevin only wants 5 cities for his sample, he has chosen more than 5 random numbers. And that's because number 2, in a truly random sample of numbers, you're going to get repeats, and that's one of the reasons that humans aren't good at being random. We tend to avoid sequences and we tend to avoid repeats. But in a truly random situation, numbers have an equally likely chance of occurring, so you'll get some repeats. Now, the first thing that we have to do is make sure all of our cities are numbered, which we've done. We've numbered New York, New York as city number 0, and Indianapolis, Indiana as city number 11. This is because Kevin's random number generator starts at 0 instead of starting at 1, so to give every city an equally likely chance of being selected, he started numbering his cities with 0. To find our simple random sample, we take the first random number that we find, either on our calculator, in our table, or in our list here. Since our first random number is 0, we go to the city with the corresponding number, in this case New York, New York, and that's going to be the first city on our list of 5 random cities. To get our second city, we go to the second random number our calculator gave us, or in this case Kevin found, which was 10, and we take city number 10, Jacksonville, Florida. And we're just going to keep going like this through the list. So the third random number we found was 11, so the third city we used is Indianapolis, Indiana. The fourth random number we found was 8, so we used San Jose, Texas. And then we run into a problem because we need 5 cities, and the fifth number is 11, but we've already used Indianapolis. So because we want 5 cities, we're not going to reuse 11. So to fix that, all we do is we just exit out, and we go to the next number. So we take city number 3, which is Houston, Texas. And that's it. So if we are provided with a list of random numbers, we want to make sure we follow that list of random numbers in order, not just kind of pick at them willy-nilly, because the numbers were randomly generated, so they're already in a random order. And if we have any repeats, we just exit out and skip on to the next number. And if you have 2 repeats, you just keep going until you find the next number that doesn't have a repeat. Also notice that when I've listed my sample of 5 cities, I haven't listed the numbers of the cities, I listed the city names. Because when I go to use this sample for whatever I'm going to do with it, I want to know what are the cities I have to investigate. I don't really care about the numbers anymore. That was just a way for me to get a random sample. Let's look at a slightly fancier version of randomization. The 5th sampling type is called a stratified sample. And I always think of geology when I think of a stratified sample. In geology, if a rock contains various strata, those would be like layers of similar kind of sediment that would create, different colors in the rock, kind of in lines going up. So a stratified sample involves grouping things by similarities. Just like in a rock, each of those strata would contain similar features. So if I want to find this kind of sample, the first thing that I have to do is to group the population by its similarities. In this case, we have 3 different shapes. We have triangles, circles, and squares. So I'm going to group my population based on those similarities. Then in step 2, we're going to draw an SRS of however many from each of our strata. Typically, you pull proportionally from the groups. For this example, since it's so small, I just went with 2 from each group. So that's what we're going to do. In order to find a simple random sample, remember you have to number your population. Since we're going to be finding 3 simple random samples, one from each group, I'm going to number the groups independently. What that means is for the triangles, I numbered them 1 through 4. For the circles, I numbered them 1 to 6. And for the squares, I numbered them 1 to 6. So I restarted my numbering for each of the different groups. Then I need to find a simple random sample of 2 shapes from each of these groups. So what I did here, because the highest number was a 6, I just rolled 2 dice and saw what I got. So I rolled 2 dice for the triangles, and I rolled a 4 and a 1. So that means I'm going to take triangle 4 and put it in my sample, and I'm going to put triangle 1 in my sample. Then I did the same thing for the circles and squares. So I rolled 2 dice for the circles, and I got a 1 and a 6. So circle 1 and circle 6 go into my sample. And for the squares, I rolled a 2 and a 3. So I put squares 2 and squares 3 into my sample box. And that's how you find a stratified sample. Let's look at how our paint company might pull this kind of sample. The paint company separates the households in Boston, Massachusetts by income tax bracket. They then take a simple random sample of 20 households from each tax bracket and record the house colors. Then they repeat this process for the households in San Diego, California. So, to determine whether a sample is a stratified sample compared to a simple random sample, the first thing you want to look for, the big distinguishing feature, is that we've got some groups going on. So the first thing you want to look for is, if you notice that word random or simple random sampling happening, check to see, are there any groups? And in this case, there are. We've grouped the households by their income tax bracket. So that's how we've decided to create our strata. We've grouped by similar tax brackets. Then the second part of a stratified sample is that you found a simple random sample from each group. In this case, we're going to look for language of a simple random sample from each of the tax brackets. And that's exactly what we have. We have a simple random sample from each tax bracket right here. So that's our clue that this is a stratified sample. So to recap, we can tell this is not just a plain old SRS because there's grouping by similarities. And we found an SRS from each of those groups. Now, that language from each group is important because sampling type 6 also contains grouping. So remember, for a stratified sample, we've pulled from each of the groups. So let's see the last sampling type. Sampling type 6 is called a cluster sample, and it also involves groups. However, these groups are typically predetermined groups. So these might be, maybe I want to sample my class and my students are already set up in groups. Or maybe I want to group a state by county. So those are already pre-existing groups. I don't have to create those groups by similarities. They're already there. So that's what we've got in this picture here. Our shapes, these are exactly the same shapes that we had before, but now they're organized into some pre-existing groups. So let's see how we find our sample. Okay, so since we're already grouped, the key difference here is in step 2, where we find a simple random sample, not of individuals, but of groups. So instead of numbering the individuals, like we did in the previous example, I'm going to number the groups. So even though we have 16 individuals, I only use the numbers 1 through 8 because I'm finding a simple random sample of groups, not of individuals. In this particular illustration, I'm going to find a simple random sample of 3 groups, and I did this by using my calculator. I used my calculator to find 3 random numbers between 1 and 8. And so the 3 random numbers my calculator gave me were 3, 5, and 8. What this means is I'm going to take group 3 and add it to my sample. And I take the entire group. And then I'm going to take the entire group 5 and add it to my sample. And I'm going to take my entire group 8 and add that to my sample as well. So in a cluster sample, instead of picking an individual from each of the groups, I'm going to take everybody only from a few of the groups. So what this means is that some of these groups are missed. I never hear from group 1, 2, 4, 6, or 7. I never hear from them. And that can cause some issues In this particular case, we had only 4 triangles and 6 circles, but in my sample, I hear from twice as many triangles as circles. So that's probably going to create an issue if triangles and circles would have a very different opinion about whatever it is I'm surveying them for. If triangles and circles wouldn't have a very big different opinion, then, it's no problem. All right, so let's see how the paint company might conduct a cluster sample. The paint company takes an SRS of 15 residential streets in Boston, Massachusetts, and records the paint color of every house on the selected streets. Then they repeat this process for the households in San Diego, California. So in order to identify a cluster sample, just like with a stratified sample, we want to see that the population has been broken down into groups or clusters. In this example, the groups are pretty subtle, actually. It's kind of hard to find them. To see that there are groups in this example, remember that we're interested in the paint colors of houses, so the individuals are houses. In this case, the houses have been grouped by residential streets. So the groups, the clusters for this example, are the residential streets in Boston and in San Diego. The second thing we need for a cluster sample is that we need a simple random sample of the groups. And in this case, that's what we have. We have a simple random sample of those residential streets, an SRS of the groups. And then lastly, we have to survey everybody that's in those selected groups. And we have that key language here. We looked at the paint color of every house in those groups, every house in the selected streets. So my recommendation is when you're dealing with random sampling and you need to identify the type, first, look to see if there's any grouping. If there's no grouping going on, it's going to be a simple random sample, if it's a random sample. Secondly, if there is grouping going on, check to see how you interview your individuals. If you take an SRS from each group, it's a stratified sample. If you look at everybody in an SRS of groups, then it's going to be a cluster sample. So those tiny little words from each and of are extremely important in distinguishing between these two, and they're very similar, so it's easy to get them mixed up. Okay, so now that we've talked about 6 different sampling techniques, let's see how we can differentiate among them. To help, I've got 3 questions for you. Number 1, how can you tell the difference between a stratified and a cluster sample? Number 2, how can you tell the difference between an SRS and a systematic sample? And number 3, how can you tell the difference between a sample of convenience and a voluntary response sample? So what I'm going to ask you to do here is to pause the video and to write down your responses in your own words to these 3 different things. Think about what you've observed, what you witnessed, and what are the little differences that you notice to help you figure out how I can tell the difference between similar samples. And then once you've done that, you can unpause the video and I'll tell you how I can tell the difference, and it might be similar to you, but it might also be different, and that's okay. So pause the video here, and then we'll review some answers. All right, so how do I tell the difference between a stratified and a cluster sample? These 2 are really tricky, as we saw, because they both involve an SRS and they both involve grouping. So the way that I figure out the difference is in a stratified, I look for the phrase from each, whatever my groups are, so from each street or from each tax bracket. For a cluster sample, I look for kind of universal language like everybody or all the things, and I look for of groups. So I look for an SRS of groups, not of individuals, and all of the individuals in those groups get surveyed. If I'm looking at an SRS and a systematic sample, that's a little bit easier to tell the difference from. Even though systematic can sometimes seem like it's random-ish, it's not quite the same. The key language for an SRS is that there's some kind of random number thing happening. So using a computer, they randomly select however many cities, or using a calculator, we randomly select, or I roll some dice and I randomly select. In systematic, it's more, you go to every 5th person. You go to every 40th thing. So you choose every nth item on the list. The third one is a little bit trickier for me because a voluntary response sample is kind of a sample of convenience. So there is some crossover between, they're both very easy for the researcher to do. So the key thing that I look at is in a voluntary response sample, the people choose to participate. So yeah, I'll do that online survey. Sure, I'll call into the radio station. Whereas for a sample of convenience, the researcher still picks who participates. They go up to people and they ask them questions, or they look out the window at the street of houses and they pick which houses they're going to look at. The houses don't volunteer. So for these two, the biggest difference is going to be who is choosing the people who participate. If the participants choose, it's voluntary response, and if the researcher chooses, then it's going to be a sample of convenience. Now, like I said, the way that you tell the difference between similar types of sampling could be different. These are just the things that I find helpful for me. Okay, so now that we have looked at the different types of sampling in one context, let's see if we can identify samples in the wilderness, is how I think of them. So we have 4 college freshmen, and they don't know what they want to major in. They don't know what they want to do. So each of them decides to investigate what fields are currently hiring in order to help them decide what might be a good major to study. So each of the 4, maybe they're friends, maybe they don't know each other, they just each decide to find their own different kind of sample, and they use a different sampling technique. So what you're going to do is you're going to decide what was the sample that was taken by each student. So we're going to look at the 4 different samples that were taken, and then you can pause the video and identify which of the 6 sampling techniques was done. And then when we're done, we'll go through all 4 of them so you can check your answers. Amina. Amina uses postal zip codes to divide New York State up into over 2,000 regions. She then selects a simple random sample of 10 zip codes and surveys all businesses in the selected areas. She identifies which businesses are currently hiring positions. What type of sample did Amina take? Take a moment to pause the video if you need to. Brent. Brent finds an alphabetical listing of all the organizations in Oneida County, and he selects every 15th organization on the list to create his sample. What type of sample has Brent chosen? Feel free to pause the video here if you need a minute to think about it. Cherish. Cherish obtains a list of businesses in New York City, and she groups them by type. So maybe they're in the arts, or culinary fields, finance, law, technology, and so on. She then interviews a simple random sample of 5 businesses from each of those types. What type of sample did Cherish conduct? Once again, feel free to pause the video if you need some time to think. And lastly, Dan. Dan attends a careers fair on campus where many local businesses have set up booths. He walks around for half an hour, interviewing the representatives at the booths that he walks by. What kind of sample did Dan conduct? Feel free to pause the video before moving on to the answers. Okay, so hopefully you've written down your responses. Another good thing to do would be to underline or highlight or write down some of the key words and phrases that helped you to make your decision. First of all, because that's going to help you focus right now, but also if it's something you're turning in, it helps your teacher know what you were thinking. And if it's something you want to use to study from later on, it helps future you know what you were thinking or what helped you make your decision. So the more you can write down, the better. Let's look at Amina. So Amina grouped New York State by zip codes. There were over 2,000 zip codes in New York State. So since there's some grouping, we know that there's going to be either a stratified or a cluster sample. So she grouped New York by the zip codes, and she looked at everybody in just a few of those groups in a simple random sample of zip codes. So because she looked at everybody in a random sample of groups, this means that Amina found a cluster sample. How about Brent? Well, Brent created a list, and he selected every 15th organization on that list. Since he went every 15th, he found a systematic sample. Cherish, like Amina, grouped her organizations in New York City, right? She grouped them by different type, were they in art or finance or law. So again, because there's some grouping going on and some randomization, Cherish is going to have found either a stratified or a cluster sample. Because she found a simple random sample from each group, she surveyed 5 businesses from each of those types. This means that she found a stratified sample. And lastly, Dan. What did Dan do? Dan went to the careers fair on campus and he just kind of ambled around for a little while, right? Dan didn't really do anything that hard or interesting. So his sample was convenient for him to find. He didn't have to go out of his way. It was right on campus, and he only even just talked to the places he happened to walk by. So Dan found a sample of convenience. This concludes our video about sampling techniques. In the next video, we'll talk about how you can conduct a different kind of study on the sample that you've collected. Thanks for watching, and have a great day!